All right, so let's take a look at covalent compounds. By comparison, covalent compounds are the easiest. The rules are the simplest, mostly because there's no work to do with any ions or the polyatomic sheet, making sure that charges balance, changing the endings, anything like that. What does make covalent compounds difficult, though, is first and foremost recognizing when we should be using these rules and when we should not be. These rules are limited only to covalent compounds, so making sure that you can tell what is an ionic compound and what is an acid is going to be the most important part to getting these ones correct. And also the other ones, once the different types of compounds start to get mixed together and you have all acids, ionic and covalent, and you need to determine which rules are appropriate, that's going to be the biggest challenge for you. So just to go over that, remember from the previous videos, ionic compounds are composed of ions. The biggest way to identify that is that there's going to be a metal present. The metal is usually the first thing written because metals always form cations. The one big exception to this, where the metal is not going to be the cation, is that we have the possibility of having the ammonium ion, NH4 with a positive one charge. So you need to be fluent enough and doing enough practice that you can recognize that NH4 signals an ionic compound. For acids, you need to recognize that when you see hydrogen as the very first thing, it is going to be an acid, and you need to apply all of the acid rules to it. Even if the rest of the compound has no metals in it and it's all nonmetals, it's not covalent. We don't use the covalent namings for it because that first hydrogen is acidic. One big exception that always gets brought up is, what about water, H2O? That has hydrogen first. True. And acids are defined as being able to produce more hydrogen ions than water because water does itself dissociate. But typically we call water by its common name of water itself and not by an acid name or a covalent name of dihydrogen monoxide. We just don't do that. But if you see hydrogen first, you're going to apply the acidic compound rules to it. Then that leaves us with, well, how do we recognize covalent? How do we know when to use the rules for today's lesson? And that's going to be if you see only nonmetals, right? So just carbon, just oxygen, nitrogen, sulfur, fluorine, phosphorus, the halogens, etc. If it's only nonmetals, we can apply these rules. Now, again, we said we don't have any charges to worry about. Right? There's nothing to balance, but because of this and because covalent compounds are just the result of elements sharing electrons, there's a number of different ways that they can bond to form and share these different electrons, depending on the circumstances, depending on the reaction conditions, depending on how much of each of the elements is present when the reaction is happening, etc. So for example, just between nitrogen and oxide, there are 6 different compounds that are possible to form between them, depending on how those nitrogen and oxygen atoms bond to each other. If we applied the rules from ionic compounds to this, we would just say nitrogen oxide because we changed the last one to end in IDE. However, we can't just call it nitrogen oxide because there are 6 different options for that. All 6 of those have different properties. They behave differently. Some of them would kill you. Some of them are used as anesthesia. Right? This is a problem. So we need to have a way to differentiate which compound is which. The rules we use for covalent compound nomenclature are pretty simple. We use a prefix to tell how many of the elements are in the compound. That's all there is to it. We're more commonly familiar with this type because of things we refer to in the news, such as carbon dioxide, carbon monoxide. All of those are covalent compounds, and we use those prefixes in there anyway. In the top right here, we see this chart of the different prefixes that we will be using, mono, di, tri, tetra, penta. Right? Most of these we are familiar with. Some of them were a little bit less so, particularly number 4, because in math we use quad for a quadrilateral, but we're using the Greek prefix rather than the Roman one. So when we have multiple of an ion, in example number 1 up here, for example, not an ion, an atom, we have 3 carbons and we have 8 oxygens. So we call that tricarbon for the 3 carbons and octahydride for the 8 hydrogens. Noticing that we do still end the compound with IDE rather than just the element itself. Right? If we had tricarbon octahydrogen, that shows 2 different molecules, one of 3 carbons, one of 8 hydrogens, rather than them being bound to each other. The only time a prefix is not written in is if it's the very first element and there's only one of them. All right, the most common example we have in our everyday life is carbon dioxide. We do not call that monocarbon dioxide. Right? If there's only one of the first element, it's ignored. And then the last one is just more of a grammatical case. is if our prefix gives us a situation where we have A and O together, or O and O. That's not something that's very common in the English language in terms of a prefix to the stem. So in terms of carbon monoxide, we don't say carbon monoxide. We get rid of the double O. In nitrogen tetraoxide, we say nitrogen tetroxide. That's all there is to the rules. So we'll do some quick practice here, and then we'll be on to do the online practice quiz like we had done for the other ones. So we're starting with C3H8. This was an example we'd already looked at, but just to reiterate, we have carbon in the first. We have hydrogen second, but we're going to make that end in IDE. So I have carbon hydride. I'm using prefixes to tell how many. 3 carbons becomes tri. Hydrides, we have 8. So we have octa. Tricarbon octahydride. Here I have oxygen and chlorine. Now there's only one oxygen, but it's the first element, so I'm not going to say monoxygen. I'm just going to put oxygen. 2 chlorines becomes dichloride. We have 1 sulfur, so again, I'm not putting monosulfur. I have 6 fluorines, so the prefix for 6 is hexa. And then we put fluoride, ending in IDE again. Number 4, there's 2 nitrogens, so di is our prefix. Nitrogen. We have 1 oxygen, so mon oxide. Again, I'm avoiding that double O in the middle there. Going from names to formulas, again, fairly straightforward. Xenon, there's no prefix, so there must only be 1 of them. Tetra means 4. Fluoride is our element, so F, and there's 4 of them. Phosphorus trichloride, only 1 phosphorus. We have chloride. Tri tells us that there's 3 of those, PCl3. Hexacarbon tells us 6 carbons. Hexahydride tells us 6 hydrogens, C6H6. And then last example, nitrogen, only 1 of those. Monoxide, 1 oxygen, gives us this as our answer. So again, covalent compounds are pretty straightforward in terms of how we name them. The difficulty is more knowing when we should not be using these rules and when we should be using these rules. The only way to practice differentiating those is to have them all mixed together and be doing practice with all types at once. So that's going to be our goal and our assignment for Thursday after you do some covalent only practice today.